Here's Calculus 2.2, and I'm sure this will be the first of several videos explaining the graphical and numerical approach to the derivative, because we have to be able to read graphs and read tables in order to do this. So the first thing is, if you look at the x, so here's your curve, and so this is the curve of f. I guess I should clarify that we'll call this function f. And if we're estimating the derivative, what we want to look at is 1, 2, 3, 4, 5, 6, 7. This first point right here, we want to draw a tangent line. I don't know how steep I want to make it. And then just count. I mean, I really shouldn't just say I choose how high that I want to make it, but so that you realize that there's only one slope at that point. But we're just going to approximate that f prime of -7 is approximately, I don't know, 1, 2, 3, 4, up 5 over 1. Now the important thing to remember is from pre-calculus that this is moving up and to the right is my clue that this is an increasing function. And then the other piece to mention is, well, what's the equation of the tangent line? I'm a big fan of writing it in point slope form, except instead of y minus y1 equals mx minus x1 is to, instead of writing minus right here, let me change colors, go ahead and add that y1 over. So that's how I'm going to write it from this point forward. So my slope is approximately 5. Again, these are approximates, except my x-coordinate does not change, minus -7. And then the y-coordinate is 1, 2, definitely down 3 from that. And that's how I would write that answer. So as we look at the next one, -6 looks like it's just the next point. Let me change colors. Maybe I'll do the same color actually. Color code this a different way. Okay, so just approximate this curve. I don't know how steep it should be, maybe up 2 over 1. So this is just an approximation. We're not going to do the exact value right now. Definitely increasing up and to the right. That's how we did it in pre-calc. So as we write this answer, I'm going to write y equals the slope of the tangent line, and then x minus the x-coordinate. And then the y-coordinate is 0, so you could write plus 0, but that doesn't change anything, so just leave it like that. Now I'm going to color code for the next one. Whoops, I forgot the tick mark for the prime earlier, f prime there. Thank you for catching that. F prime of -4 is approximately, now it's, I shouldn't say approximately now, because it was intended to be at the top of that curve. So anytime we get to the top of that curve, we're going to say that the slope is 0, which should make perfect sense. And this is a relative max. So instead of saying increasing or decreasing, we're going to say it's a relative max. And so what's unique about this is now the slope is 0. Well, 0 times anything is just 0. So all you have to do is write the y-coordinate. Y equals 2. I hope you're okay that I didn't write plus 0 here. I didn't write plus 0 there. It's the same thing. So let me change colors again for f of -2. So f prime of -2 is approximately, because we're just drawing it on the graph, we're not actually numerically finding it out. If I'm judging, I would say that looks like it's about -1, like down 1, right 1. You can probably tell the color code that I'm trying to do there. But it's going down and to the right, so this would be a decreasing function. So as I write the equation of the tangent line, I like to start with the slope, and then x minus your x-coordinate, which is -2, makes it x plus 2, and the y-coordinate at that point was supposed to go up to 1, so I'm going to write plus 1. The next one is f prime of -1. I think it looks a little steeper there. If I go up to my graph, I don't know what I should make it. Kind of looks like it's down 3 over 1. But the important thing is it's going down and to the right, which makes it a decreasing function. So y is equal to the slope, x minus the x-coordinate. And then the y-coordinate at the point, it looks like -1, so it is -1 there. And now the next one. Probably already tell what color I'm going to. F prime of 1. Now again, the way it's intended, probably don't need approximately, but at f prime of 1, you can see it's a relative min, and it has a horizontal tangent line. Maybe I should write that down, because that's an important thing. Here, here, and there's another one. We call these horizontal tangent lines. That's going to be an important fact. I feel like a soothsayer, kind of warning you of future things. But anyway, relative min with a slope of 0 for this horizontal tangent line. Instead of writing y equals 0, well, 0 times anything is 0, so I just need the y-coordinate there, which is 1, 2, 3, -4. So y equals -4 is your equation of the tangent line. Well, it looks like we're increasing it back to increasing for f prime of 3. I hope this isn't boring you, by the way. This is worth the watch. So as I'm looking at this tangent line, I don't know if it's back to being up 3 over 1. Let's see, like up and to the right. I don't know. I'm going to commit to about 3. What's important is it's going up and to the right to say that it's increasing. So as I write this equation, y equals my slope, x minus the x-coordinate, and then the y-coordinate at x equals 3 was supposed to be -1, so I'm going to write -1 right there. And the next one, what color am I going to use? Yep, you got it. It's a horizontal tangent again. So f prime of 5 is supposed to be 0. It's a relative max. You already guessed it. I'm going to make a little dot here. This is a horizontal tangent, and now I can just use the equation. Y equals, well, 0 times anything is 0 for the slope, plus your y-coordinate of 4. Then we have one more to do, and we're back to decreasing for f prime of 7. It's down and to the right. And this one looks a lot steeper than previous ones. So I don't know if I should make it like -5, but the important thing is that it's definitely going down. So it's a negative slope. You can probably hear what the next note is going to say. And the y-coordinate there, for the sake of continuity, is -1. Alright, so please pause the video at any point. Fill out this stuff. And before I move on, I want to point out with a highlighter what you notice is happening for these red ones, and what is happening for this one. What's unique about the increasing functions and the derivative, and the decreasing one in the derivatives. And I already pointed out that when the derivative was 0, it was a relative min or max, which we call horizontal tangent lines. So again, pause the video before we move on to the next piece. So instead of going back to and writing all of this out, I figured I would just share the answer key, because it's worded a lot better than probably how I would write it, and I would just explain in the same way. So as you look at rule number 1, you should notice that the derivative is a positive number. And what that means is if we're looking at the derivative at a specific point A is positive, then the graph of f of x is increasing at that x value. And on the flip side, if that derivative was negative, then the graph of the derivative was decreasing at that x value. And this 3 and 4, you might be saying, is obvious, but these are your reasons as well. So at some point you'll be asked, is this x value a relative max or a min? Not only would you have to say its derivative is equal to 0, you have to say the behavior on the left and right side. So if the function goes from a positive slope to a negative slope, so in other words, the derivative goes from, I kind of said, the derivative goes from positive to negative. So the function goes from increasing to decreasing. The only way to go from increasing to decreasing is if we hit a maximum at that point. And on the flip side, a function is a relative min when it goes from a decreasing to an increasing, but we don't want to say that. We want to give all of our answers with calculus. So we say the derivative is 0, and the derivative changes from a negative to a positive value. So that means if the derivative changes from negative to positive, the function changes from decreasing to increasing. Make sure when you justify your reasons, you give your answer using the derivative. I'm hesitant to stop there. I guess I should mention that you should give your answer in terms of what they give you. Now, they usually give you the derivative when you're justifying if it's a min or a max. So again, pause the video, copy this down, and I'll see you back at the notes. Now, I do sort of have issues with how this is explained, and I have my own issues with it, because the x values in this table are actually given in the problem. So when you estimate a derivative, you actually have 3 options, because all we know right now is f of 0 is equal to 1. We don't know what the derivative is exactly at that point. So when you're estimating f prime of 0, you just have to just remind yourself that the derivative is the slope. So what you can do is you can use these 2 points to estimate the slope at that point. You could use these 2 points, or you can use the outside points. Now, my preference is to use the outside points, and as a reminder, slope is just y2 minus y1 over x2 minus x1. So if I were doing this problem, I would use the y-coordinates, so negative 3 minus 2, over the x-coordinates, so 1 minus negative 3. So as I'm doing that, I'm saying I get negative 5/4. So what does that mean? Well, we have a negative slope, so that's your clue that this is going to be a decreasing function. So if we were to write this equation, I would write it as y equals, and this is just an approximation, by the way, because this is not exactly the slope at the point, it's just an estimation. X minus the x-coordinate, I'll go ahead and write minus 0, but minus 0 is not going to change anything, and then plus your y-coordinate, just like what we did before. Now, before I move on, maybe I'll just pause right here to do the next video. The reason why I have an issue with the way this is written is typically on an AP test, they're not going to ask you to estimate a value that's in the table. Sometimes they do, and that's when you can do one of the 3 different things I mentioned. What they usually ask you to do is estimate the derivative of, let's say, 0.5. So then you would have to use these 2 values, because 0.5 is halfway between 0 and 1. That was important to mention before moving on, but I'm going to get rid of that. I'm going to stop the video and continue with the second one.